in the end of this month. It will be held either in the afternoon or uh, in the morning. Maybe in the morning, but either Saturday or Sunday. But we want to make sure that maybe we can help the makeup exam on Saturday. So it's okay if you got not so really high score. It's okay. I believe you will do better next time. And if you have any problem, you can contact me by email. And if you're in Taiwan, we can meet person to person, and I will help you if you need some question, especially for your makeup exam. So, Chayo, I hope you're doing better for the makeup exam. So today I heard that you guys will have a quiz for chapter 5, right? May I know when the quiz will be held? Thursday. This Thursday. Oh, okay. Okay. Oh yeah, and I hope you already finished your homework since we got not some, a lot of questions from chapter 5, especially 5.3 and 5.5. So it will be a good practice. So today's class, we will discuss maybe some question also from chapter 5. And I hope you can really pay attention. Maybe for today's class, I will do it with you guys, and maybe you can do in your own place. So just prepare a paper and pen, and we can try to solve some questions that I provide to make sure you will be ready for the quiz this Thursday. Okay, so I only provide like 4 questions. Yeah, 4 questions, and we will do it together today. And if you have any question, just raise your hand and uh, tell me which part that you still don't understand. Okay? But first of all, let me share the screen first. Okay, as always, welcome my fellow calculus crewmates. I hope there is no imposter among us. And this is the attendance. Please scan it and fill the attendance. And I also provide which number that you still don't understand from the homework. Maybe if we have time, we can discuss some of it in this class. If no, maybe I will provide the answer key later in the Moodle. Oh, there's some question still. Okay. Okay, I hope you all already scanned it. For some of question from homework that you still don't understand, if we still have time, I will discuss it in this class. But if no, I will provide it through PDF file, and I will upload it in the Moodle. So just check it later. But for today, My focus is we will discuss some numbers that maybe will occur in your quiz this Thursday. Okay? Mm. Okay. Some from section 5.5, number 100. Okay. Okay. So let's start. Okay. So, as you guys can see here, I already provide you like 4 questions. And from all of these questions, maybe some or maybe all of them will occur in uh, the quiz for this Thursday. So let's discuss it. And if you have any question, you can ask. Okay. And so let's start with this number. Maybe you can provide pen and paper and you can do by yourself first. And then later I will show you step by step how to solve this problem. So the first question is let gx equals to the integral 0 to x of function t dt, where f is the function whose graph is shown. Question A, use the fundamental theorem of calculus to derive the function g. And then try to find g3, the first derivative of the function of g at 3, and the second derivative of function j also at x equals 3. And this is always the problem. Does g have a local maximum, a local minimum, or neither? At x equals 6, and local maximum at x equals 9. And this is the graph. Maybe I give you some time to do it by yourself first. I think this part of question is from section 5.3, the fundamental theorem of calculus. Last week, you guys already done really great. I think that's the first time this class have answered all correct for the practice. So I believe, and I hope the quiz for this Thursday will go on smoothly. Okay? So let's do it together. And again, if you have any question, you can just raise your hand. We have the tools here, raise hand in the Google Meet. So just use it and just ask any question that you want to ask regarding this question. Okay, so let's do it. Gx equals to this function. First question A. It's pretty easy. Use part 1 of the fundamental theorem of calculus to graph g action. So because of g x equals to x f a dt, Then the first derivative of gx, pretty easy, will be fx by first fundamental theorem of calculus, FTC, part 1. Therefore, the A, I think it's pretty easy, right? Okay, next. For B, first one, the function g at x equals 3. So remember, this function is based from this part. So you just can edit. It will be equal to 3. You input the x3 here of this function dt. So from this function, you can see from the graph 0 to 3. It will be around this one. So maybe one thing to make it easy, you just can divide it. So the triangle plus the trapezoid here. Okay. Remember, the integral means the area under the curve. So first is the triangle. Half times 2 times 5 from 1 to 1, 2, 3, 4. So 1, 2, 3, 4, 5. The height. And then plus the area of the trapezoid. Equals 9. Okay, I think it's easy. The first derivative means you use this function, g derivative of gx. So it means f3, it equals to 3. Why 3? At x equal 3, the function f it's equal 3 here. Okay, and how about the second derivative? It means the first derivative of the function f. You still remember the terms of the first derivative? It means the gradient or the slope at that point. So it means uh, the slope at x equals 3. So it means this part. Okay. So you can use 1 minus 5 over 4 minus 2. Two. So the slope, it means the slope between 0.25 and 0.01. So you can see, so the slope is between the point 25 here and 4.1 here. So that's why 1 minus 5 over 4 minus 2. Okay. C, does G have a local maximum, a local minimum, or neither at x equals 6? X equals 6 here. Is it local maximum or local minimum? At 6, at x equals 6, G has a local max. Why? Because f equals to the first derivative of g. Remember the question here? The function here is the function of f. Okay? The function of f. G is the function of the area of f. So it means the local maximum is happen at 6 because it changes from positive to negative. What I mean by change from positive to negative, at 6 here, it's changed from positive to negative at 0.6. And so it's pretty easy for, does G have a local maximum, a local minimum, or neither at x equal 9? Because it changed from minus to positive here. It means 9. At x equals 9, G has the local minimum. Okay? So pretty much that's it for the first question. If you have any question, just raise your hand or just ask. Any question maybe first? Remember, gx is the function of the area under the curve of f. So the question provided here, the figure provided here is the function of f, not the function of g. Okay? Mm, that's quite easy, I think. Okay, if you don't have any question, let's practice some they provide, but I think this is the same. Yeah, maybe the same. Okay. Second question, a function of h equals to the integral from 1 to square root of x z square over z fourth power fourth plus 1 dz. Okay, maybe you can try first. Try to use the u substitution. Maybe I put the hint here. You can use u equals to square root of x. Okay, let's try to do it together. So when you substitute the square root of x equals to u, it means the derivative. Yeah, I think you guys already know this, right? Equals to 1, 2, okay. And also, dh over dx equals to dh linear. So if you derive it over the x, you can change to dh over du times d over dx. It's just the same, right? If you get rid of the du, you will have the same. So by fundamental theorem of calculus part 1, so you derive each side, hx, and this function, you derive it, you will get, maybe I write like this, d over dx h x equals to d over dx 1 5 c 4 c 2 d c. Oh, sorry. There's no. So you will get hx equals to d over du 1 to u plus 1 plus 1 dz times du over dx. Remember, this is the function of h, so it means dh over dx, and you change from dh du times du dx here. Okay. Then it will be equal u u4 plus 1 times du over dx. Remember, you have the du over dx here, so you just can substitute to the equation. Yes. And remember, you have u equals to square root of x. You substitute the u here. Subs u equals to, and you will get x squared x times 1 over square root x, and you will get square root x over 2 times x squared plus 1. Okay. If you have found these questions and they want to know the derivative of this function, you can use the fundamental theorem of calculus part 1 and just derive it as usual. Okay. If any question, just ask. This is for the third problems. If f is continuous, it means you can derive it or make the integral from it. And the integral 0 to 4 of the function fx equals to 10. Find that function. This question is from section 5.5. So you can use the U substitution. Maybe I can make the hint here. U X. Okay, let's try to do. Remember the U substitution. It means the derivative will be du over dx equals to 2. Du equals to 2 times dx. Okay. And then substitute to the question 0 to 2x dx means you substitute to make the function of fx. So you will be changed to be 4 f q times d. Is equals to f d. You now from this one you will get 10 f. Okay, pretty easy. Any question maybe? I think for this part we don't need to discuss it because it's quite similar with the first problem. And I think we still have some time to discuss the homework. Is there any problem? So basically, uh, these three problems most likely will occur for your quiz this Thursday. So just prepare for it. And maybe you need to focus on section 5.3, which is the fundamental theorem of calculus, and 5.5, the U substitution. So that's why your homework also from that part. Okay? Maybe we can discuss some number from what you asked. Most of you want to ask 5.5 number 100. Okay. Let me see the question first. Yeah. Yeah. Patient for a moment. Okay. So I believe this is the question, huh? If f is continuous, prove that 0 to phi fx cos x dx equals to 0 to f sin x dx. It's quite complicated, huh? This is the number, right? 5.5 number 100. Sun. Okay, maybe we can still have some times to discuss. If no, I will provide the answer key later in the module. If f is continuous, prove that blah blah blah, and use part A to evaluate blah blah blah. Okay, let's try to do that. Maybe I need to like this. Okay. Okay. You guys can see it, right? Yeah. If f is continuous, prove that blah 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 blah. So you just can, you have to make sure this one equals to this one. How? Let's try this way. For yeah, okay. For A, so 0 to pi over 2 f cos x dx. First of all, try to change it to the function using sine. How? It means you can do it like this. 0 to pi over 2, the function of sine. How you change the cos function to sine? Easy. Phi over 2 minus dx. Phi over 2 minus dx. It's equal, right? Okay. Then let u equals to pi over 2 minus x. So du will be minus dx. You substitute this one 5 over 2 minus x to u. So you got this one. So it will become you substitute the u and swap this, and it will become 0 f sin u minus d. Okay. Then if you swap this one, you will get 0 to f sin u. So it means it's equal to 0 over pi over 2 f sin x dx equals to this. That's for the A. Okay. And use part A to evaluate this one. Okay. Let's see. Okay, remember, since the function is the same, we can try to evaluate it in the same way. So in part A, let fx equals to x squared. So to cos dx will be equal to the sine. Remember this part. Why it equals? Because we assume that the function of x is equal to x squared. Okay. Now, if we try like this, integral of 0 to cos x dx plus L pi over 2 x dx. Remember, this will be equal to 1. Why? Because you can write it like this. Pi over 2 cos sine 2 x dx. Will be 0 pi over 2. Remember the function of the trigonometry? 1 dx means equals to pi over 2. Since sin x square is equals to the cos x square, we can assume so 2 of 0 to cos x dx is equals to y, because we assume that the cos x square is equals to sine x square, right? So it means 0 pi over 2 cos 2x dx equals to pi over 4, which means also the same with this one, x dx. Okay, that's for number 100 for 65.5. For other, I'm sorry I didn't have much time to discuss for the other number, but I will provide you the answer key later in the Moodle, so just stay tuned in the Moodle. And thank you for doing the homework. I think just that's it for today. If you have any question, you can ask me by email or in the Moodle. And if you want to meet person to person, you just can email me and we can have some time. Okay, thank you. And Jaya for your quiz this Thursday. Bye bye. Thank you. Thank you.